Sheri Johnson of Catspaw and Instatract is going to be talking to us about CAD hard surface modeling. So Sheri, welcome.
Hello. All right, let me get my screen shared here and started. Now, last week, we actually discussed what CAD was. We defined it and determined the different types of CAD. And tonight, we're going to focus on one of the methods, which is hard surface modeling. And basically, that's anything that is mechanical or building or an engine, anything that has a lot of flat surfaces. Now, when you're looking at doing hard surface modeling, the different CAD packages, we have basically three different offerings. We have wireframe, which basically you draw kind of like you would on a drafting table with lines, and that's all you see are the lines for the actual object you're drawing. There is surface modeling, which allows you to control the curves and the shape of the surface of an object. It's great for complex geometries, but it's not so good for milling and it's not so good for 3D printing. Then we have solid modeling. Basically, solid modeling uses primitives or basic shapes, and you add and subtract those shapes to come to your final object. This type of modeling is definitely what you want to be doing if you're doing 3D printing, because you need solid objects to 3D print. I'm going to take a look at how, and I've got some examples here showing these different types of modeling. The first one is the wireframe. And as I mentioned before, it draws things with just lines. That's where it leaves the actual model is with lines. And this is a short little 2-minute video, which I think it's a little bit less than 2 minutes. But this harkens back to the original days of AutoCAD back in the 1980s. This is how you would have been drawing then. And this is probably as far as you would have gotten back in the 80s, would have been with these line drawings. One of the things you have to know with line drawings is where all of your points are. If you don't know where your corner points are, your end points are, and you're trying to connect your lines, you're going to have a really weird looking object. And I can remember back in drafting class, I hated doing these because invariably I would have one corner off from another. But you get your basic shape. You can see where it is. It's going to be three-dimensional, unlike your old 2D drawings, because what we're focusing on in the rest of the CAD series is going to be 3 dimensions, because that's what you need for CNC machining, which we'll talk about in future segments. It's what we're going to need for 3D printing, which we're going to talk about in future segments. But I wanted you guys to see this because there's still some places where you might want to use the wireform. And that's basically what you get with your 3D object in wireform. Not very impressive at all. Next up, we're going to take a look at surface modeling. You kind of will start, and you'll see in the next example, you're going to start with a wireframe, but then you're going to add a surface over it. You can really define complex parts easily. And surface modeling, you can actually do some CAD because if you're doing a router, you're actually routing out the top surfaces. It's routing out the top of the box. Not good for 3D printing, but good for doing CNC machining. One of the bad parts is when you put things together with a surface, you might not get the edges touching. There could be gaps, there might not be gaps, it could be overlapping, and it's really hard to tell when you're putting all these surfaces together whether or not you actually have one cohesive object. And a lot of programs don't see these as one cohesive object. They see it as all these little piece parts, which makes further processing for using in other tools very difficult. Here's an example, and I have sped this up dramatically. Another little 2-minute video showing how one would do a surface model. And you can see it kind of looks similar to the line drawings because we're starting with lines. And we're basically building a skeleton. You can kind of think of it as building a skeleton and then putting material on top of it. Here, basically, you're going to be building the framework, and then you're going to be covering it with a particular type of material or shape. I'm just going to let this run here for a minute. When you're doing surface modeling, notice there's, and this is actually done in Fusion 360, which is great. Fusion 360, which we're going to discuss a little bit later, can do all forms of modeling. It can do solid, it can do surface. If you look at the menu, you can see that it's designed where you can do sheet metal, you can do, this is an older version, but you can do mesh. It's also more precise. You can see here a lot of it, they're dealing, as they're drawing this, with a lot of measurements. We're checking angles, we're checking curves. Kind of see them fling in there. Again, you have to deal with your points. You can modify your curves by different angles. The great thing is with using measurements is you can actually match your angles, which is good. I'm notorious for not getting my angles matched. And you can see here, we're kind of developing the skeleton shape here. We've got the skeleton, all the outlining done. So it's kind of like wire form with clothes on. As you see here, they're starting to add the actual surface material. You can see how they're shaping that surface to match the frame. And you can do a lot of modification here with the surface. Now, as you're looking at this, this is a surface. These walls have no thickness. You cannot 3D print this model at all. You can add thickness to the walls and your 3D model would be just the walls. But without thickening those walls, it cannot be printed. I'm not sure if it could be machined or done on a laser cutter either. But you see, you can get your nice shiny object there with its skin on, or fabric, if you will. Next, we're going to go on to solid modeling. And solid modeling is used a lot for CNC machining, laser cutting, and 3D printing. So it's kind of taken over and is kind of the main form of modeling these days, especially when you're doing 3D modeling. To use the solid modeling, again, I mentioned that it's done by adding and subtracting basic shapes, squares, cubes. You have to start thinking when you're modeling, when you look at something, it's like, oh, that's a square and that's a circle. If I put those together, I can come up with this object. To me, solid modeling is easy. It's easier than the other two forms, which I have done in a previous life. And here's an example of solid modeling, which Tinkercad is excellent at. If you're looking for a beginner's piece of software that is easy to use for solid modeling, Tinkercad is it. Tons of tutorials online. They use it in classrooms. Kids are very well versed. If you have problems with Tinkercad, go to your local elementary school and say, hey, have you guys used CAD? Show me how to do this. Which is sad because my next door neighbor who's 11 is amazing at what she can do with Tinkercad. It's truly amazing. And you can see here, they're just adding various shapes, rectangles, parabolas, an open circle. They're just grouping things together, adding and subtracting until they get what they want. And you can see this goes very quickly to create an object and very, very easily. And since it's solid, everything already has a thickness to it. It's a solid object. It's boom, it's there. Which is why solid modeling is what you need for 3D printing and most of your CNC machining these days, because you're working with solids. And right now we're just putting in some mounting holes so that we can kind of mount this flange onto something. And a lot of people go, oh, Tinkercad's too easy, it's a toy. But if you join some of the Tinkercad forums, it is amazing what people are doing with Tinkercad. Tinkercad now actually has a model simulation where you can actually simulate chains and wheels and see how things work together, which is really cool. So one nice, easy, put together flange. I mean, that was quick. In doing my research, I discovered that there are over 210 different 3D modeling CAD programs available. I am not going to present all of those. What I did was I took the list of the top 10 for 2024, and from that list, I pulled the top 16 that were mentioned. AutoCAD, still number one. It does 2D, it does 3D. You've got Onshape, which is a really cool program, and we're going to discuss each one of these briefly. Rhino 3D, love that one. SolidWorks, it's amazing how many of these I've used. Shaper 3D is one that I currently use because it's like Tinkercad on steroids. I love it, and it's not as complicated to me as Fusion is. We've got Autodesk Inventor, which is designed for people who are making things, and it has a lot of simulation. FreeCAD has a lot of functionality. It actually has model repair built in. Kind of a screwy looking interface, but it's free. SketchUp, I know several folks who use SketchUp to create their models, and it has its advantages. Blender, you're going to see Blender a lot. Blender is kind of the one software that does everything. It can do figures. It can do organic modeling, which we talk about next week. It can do hard surface modeling. It can do anything and everything. Its interface is bizarre. I have been trying to learn Blender for the last 5 years, and I still haven't got it. It's too confusing for me. 3D Studio Max, another one that's been out there for a while. Fusion 360, which is the one that AutoCAD is, or Autodesk is currently pushing for 3D modeling. And it actually has export utility to directly drive CNC machines, which is really cool. Tinkercad, which we just saw in one of our examples. Maya, which has been around, and it does hard surface modeling, but it's more geared towards animating those models. SelfCAD is another one out there. Design Spark. CATIA, which has been around forever, very high-end program, and you're going to find out shortly why it's one that I don't use. BricsCAD and OpenSCAD. OpenSCAD is on here, but it's kind of unique in that you don't actually draw objects, you write the mathematical formulas and it creates the image. And we'll kind of show you that. Now, these are the most recommended for 2024, according to all the experts out there. Now, taking a look at the pricing, this is going to help determine whether or not the software is for you. And I'm going to go ahead and share this as a PDF with active links, and I'm going to put it up on the New Tracks Facebook page, so that you, if you want to, you can click these links and actually see the software and download maybe free trials. AutoCAD's $2,000 per year. A lot of these have all gone to subscription-based, which I hate. I'm a one where I want to buy the software, it's done, and I'm going to use it until it never runs on my computer again, or I'm going to keep that computer from 20 years ago so I can keep using that software. Unfortunately, things have gone cloud-based and you have to pay per year. So AutoCAD is $2,000 per year. There is no free version. They have a free version, but it's only for 2D drawings. It doesn't do any 3D. Onshape has been on the market and been out for several years. They have a free version, which basically has all the functionality of their full version. The caveat is all the files are saved on the cloud on their server, and they are made public. They go into a library, so anybody can go to that library and find your file and use it. Well, I'm a business. I don't want to be sharing my files with everybody because I need to print them and keep them proprietary to me. So using Onshape, their free version, is not an option. Now, for the hobbyist, it's going to be great. It's also $1,500 a year if you're going for the full-fledged version, which does keep your files private. SolidWorks, this is an interesting character. SolidWorks has 3 different levels. There is the SolidWorks, which you have to contact sales. I'm like, okay, if you've got to contact sales and they got to quote me a price, I already know that I can't afford that version of SolidWorks. They have a cloud-based version, which is $2,580 a year. And then they have something called 3D Experience SolidWorks, which is $48 per year. So it's kind of a stripped down version of SolidWorks, and it's geared towards the hobbyist and the maker spaces. And I don't know how many of you are familiar with maker spaces, but if you have a bona fide maker space, you can get 3D Experience SolidWorks for free. But you have to be a certified maker space and show that your maker space and how many people come to it and use your space. Shaper 3D has a free version. It's very basic. It doesn't output high resolution models, and you can only have, I think, 2 files or at a time. However, it's much more reasonable. It's only $299 per year. Autodesk Inventor, and you're going to notice as we go through the list that a lot of the programs on here are now owned by Autodesk. They used to be independent and owned by other people, but Autodesk keeps buying them up. Autodesk Inventor is another one of those where it does a lot of solid modeling, and it has a lot of animation or simulation where you can create interactive gears and things like that, and it will let you test your mechanicals. So let's say you were trying to test a linkage that you had just drawn. Inventor would be great for that because it has that level of simulation. But it is $2,500 a year. Next up, we have FreeCAD. It's right there in the name. That one is free. A lot of functionality. It can do all sorts of things. It has, again, what I would consider a unique interface. It's not quite standard, but it does have a lot of functionality. And if you wanted, I would say it would be a good place to start if you want to take the time to learn the interface. SketchUp has a free version, which is cloud-based. It's online only now. They used to have a free desktop version, but I can't find that anymore. And its annual plan is $119 per year if you're going with the full version where you can get all the features for SketchUp. Blender is free. It's open source. And again, it is the Swiss Army knife of modeling. It does everything, but has one of the most convoluted interfaces I have ever seen. I've been trying to learn it. I have given up. Some of you may look at it and go, wow, this is really easy. Cool. Next one up, 3ds Max, which again, another one that Autodesk bought out, is also geared more towards your animation and sort of your online gaming and that type of thing for making characters. And it comes in at $1,875 per year. Next up, Fusion 360. Again, we're with Autodesk. They have a free personal use or hobbyist version, which has all the features where, well, I would say probably 80% of the features of the full-blown version. You're limited to 10 editable files at a time, but you can archive files and bring new ones in to edit. They also have the full-fledged version, which is $680 per year, which the functionality of Fusion is, it's probably worth it. Tinkercad and Fusion are basically my 2 go-tos. Tinkercad is free. It is online based. They do have a version that runs on an iPad, and it will also run on a Microsoft Surface tablet / computer. They do that because it's used a lot in the schools, elementary all the way up through college level. They have, and once again, a lot of tutorials, libraries, a gallery where we can find stuff that's already done. I do want to make a note at this point about all the stuff we're seeing from Autodesk, and we're going to see a couple more, I believe. Autodesk offers a token-based pricing where you can pay so much and then use it so many times a year. So you can buy so many tokens and then use it 12 days in the year, but they don't have to be in a row. I'm just briefly here. We've got the more software. Again, I'm going to put this up on the new tracks page so you can kind of go over it and click the links and take a look at this. And my last slide, because people ask what's best, what's easiest, and all of that is subjective. So what I've done here is just kind of a few unique features of each of the software that I see lend itself most to those of us in the hobby industry who are trying to create things, buildings, and objects. One of the cool things that Tinkercad which is also owned by Autodesk, it has a feature, a send to function. So you can actually send your solid model you created there to Fusion as a solid model and edit it there as a solid, versus having to deal with mesh or mesh things, which we'll talk about next week. Which next week is the 26th, where we'll talk about freeform and organic, and then we'll have specialized programs on the 3rd. Any questions?
Well, Sheri, you know how totally incompetent I am when it comes to all of this. Pick a program. Where would I start?
Tinkercad.
Thank you.
It's the easiest, lots of tutorials. Start with Tinkercad. And all the others, kind of, once you learn Tinkercad, you can make your way into the others, because a lot of the way you do things is going to be the same. But start with Tinkercad.